In this video, we will cover the below topics: keywords, data types, qualifiers, identifiers, variables, and format specifiers. So keywords are words that have special meaning to the C compiler. In C, we have around 32 keywords, and all these keywords, they have a special meaning and they are used to perform certain functionalities. So these keywords are further divided into different groups. So first is qualifiers. In qualifiers, we have short, long, signed, unsigned, const, and volatile. In case of data types, we have int for integer, char for character, float for decimal point numbers, double, void, struct for structures, union, enum. In conditional, for conditional statements to evaluate certain conditions, we have if, else, switch, case, default, continue, break, and go to. For storage of the data, we have auto, register, static, and external. So these are called as storage classes, and they have 4 different keywords. Then for looping, we have for, while, and do. Then we have certain miscellaneous keywords, size of to determine the size of the variable, then type def, and return. So data types, they are used to specify the type of data a variable can store. So in C data types, we have basic data types, derived data types, and user-defined data types. So these are the basic data types, and then they are the building blocks of other data types. So we have int for integer, char for character, float, double, and void. In case of derived data types, we have array. So array is a collection of similar elements. So if we have an array of, say, integer array with 5 elements, then all the 5 elements will be of type integer. So they have homogeneous elements. Then we have pointer. Pointer points to an address of a variable. Then we have pointer references. So in case of user-defined data types, a user can define the data type based on the use case. So first in this is structure. So in structure, we can have elements of different data types or elements of same data types. It is also known as heterogeneous. So in structure, we can have different elements of type integer, character, float. It again depends on the use case. Then we have union. Union is similar to structure. They have some basic differences when it comes to size and their use. Then we have enum. Enum are nothing but named integers. Now this is a program to print size of different data types. So here we can see that we are printing the size of char, integer, float, double, short, long, then long, long. Then here we are printing size of expressions for character C, then 1 plus 3, then 1 plus 3.5. So here this is floating point and this is integer. In this case, both of them are integers. Then we are printing the size of pointer. This is integer pointer, this is float pointer, this is double pointer. So we will see the output of this code. So here you can see I have run the program and we can see the size of character, that is 1 byte. Size of integer here is 4 bytes. So one thing to note here is these sizes, they again depend on compiler and they differ from compiler to compiler. But for this particular compiler, these are the sizes. So size of float is 4 bytes, size of double is 8 bytes, size of short is 2 bytes, size of long is 8 bytes, long is 8 bytes. So this size of expression 4 bytes, 4 bytes, this is 8 bytes because one member we had as a floating point. Then these are the size of pointers, 8 byte, 8 byte, 8 byte, 8 byte. So all the pointers here have similar size. So qualifiers, Qualifier is a keyword that is used to modify the properties of a variable or a function. So this is the general syntax. We have like storage class, qualifier, data type, variable. So examples, const, int, by 3.14. So these are the qualifiers: short, long, signed, unsigned, const, volatile. So whenever we use these keywords, we modify the property of the variable. So in this case, const is the qualifier, in this case signed, in this case unsigned, in this case unsigned, and in this case we have two qualifiers together, const and volatile. Note, if we don't explicit specify the unsigned qualifier with data type, they are signed in nature. So by default, like in this case int, this is signed. For unsigned, we have to specifically mention unsigned. Now char text, the range of this is -128 to 127. Negative numbers are represented as 2's complement. Then int num. Int num is basically signed integer. So unsigned char text. So in this case, the range would be from 0 to 255. In case of signed character, the range is from -128 to 127. So this is the character range. So usually signed character, they have a range from -128 to 127. So if we add +1 to 127, then it will roll back to -128. So here we have an example code. We have character C127. So by default it is signed. Then we have another unsigned character 127. So what will happen if I add +1 in this and +1 in this? So in the first case, this value will roll over and we will get the output as 128. But for the unsigned character, +1 would be added and we'll get the value 128. And in the case of this unsigned character, if its value is 255 and we add +1 to it, then the value will roll back to 0. So we will see the output of this code. So you see initially the value of character is 127 and unsigned is 127, and when we add 1, the signed value becomes -128. It rolls back to the first value, and the unsigned character value, it becomes 128. But when we are adding +1 to the maximum limit, that is 255, it rolls back to 0 because its range is from 0 to 255. Rules for constructing variable names. So a variable in C is basically a container which holds a certain value. So variables are like the meaningful names used to identify the different data types. For example, my name is Rishu and it is used to identify me. So similarly, for every data types, we have certain meaningful names which is used to identify that particular data type. So we have certain rules that we have to keep in mind while declaring variable names. First is a variable name must be between 1 and 31 characters long. A variable name can only contain letters, both uppercase and lowercase, digits, and underscores. The first character of a variable name must be a letter or an underscore. It can't be a number. No commas or spaces are allowed in a variable name. No special symbols other than underscores are allowed in a variable name. Next is variable names are case sensitive. Next is you can't use keywords or reserved words as variable names. So here are some examples of valid variable names. So int my variable, int total sales, first name, last name, int age, int weight. Here are some examples of invalid variable names. So here it is int 123 ABC, as it starts with a number, so it is an invalid variable name. Here it is int my space variable, as it contains a space, so it becomes invalid. Next is int exclamation mark my variable. It contains a special symbol, so this is not a valid one. This is int if is a keyword, so this is also not a valid variable name. It is important to choose meaningful variable names that reflect the purpose of the variable. So sometimes we just write int I, int a, but this I and a, they don't hold any specific meaning. So as developers, we should always use meaningful variable names so that your coding will become easier and we will be able to read and understand the code. Format specifier. In C, format specifiers are used to control the output of formatted data. They are used in functions such as printf and scanf. A format specifier always starts with a percentage character. So here are some of the most common format specifiers. %d, it prints a decimal integer. %c, it prints a character. %s prints a string. %f prints a floating point number. %e prints floating point number in scientific notation. Then %x prints integer in hexadecimal value. %X prints integer in uppercase hexadecimal. So here we have a code snippet where we are using different format specifiers to print certain numbers. So we have this number 999. So here we are printing the octal value. Here the hexadecimal. In this case, unsigned decimal value for the number. Here we are printing character %c, ch. So ch is 65. 65 is ASCII code, and internally the compiler changes it to a specific character value, that is A. Here we are printing floating number for this number. Here we are using float for typecasting purpose so that we don't get any compilation warning. So similarly, %e is used to denote scientific notation, and %p is used to print the address of number. So here the address will be printed. So let's see the output of this code snippet. Here we can see that the decimal number 999. Then one more tricky part here is, in C, we don't have a format specifier to print the binary number. So suppose we want to print 999 in the decimal format, we will have to write our own code for that. So here that code snippet is written. So we are iterating over it, and then we are right shifting it and then ANDing it with 1. So this logic will print the binary format of the number. Then here we can see the octal, hexadecimal, unsigned decimal, floating number, and exponent value is printed. And lastly, the address is also printed for the number. So now suppose I want to print this particular person throwing basketball in the net. So we can represent raw string in this format. So printf, we have to use R, then quotation mark, and here we just have to copy paste the string details. So any ASCII art we can print. We just have to copy paste it in the string details. And when you give run, that particular raw string will be printed in the console output window.